Hello, everybody. Thank you so much for joining us today. Great to have you all on the line. This is a next in our series of kind of bi-weekly workflow videos. This week we are looking, of course, at Verity and Verity Photo, which are our products focused on construction QA/QC. Though we do certainly have some other uses for those products. But yeah, with that, some quick housekeeping. Everybody is muted during the presentation except for the presenter. But you can ask questions via the chat throughout the session. And we will kind of at the end, we will have a little Q&A time. And during that time, we will go through and answer those questions as best we can. If we don't get to everybody's question, we will follow up after the webinar and try and answer any leftover questions. We are recording the webinar and we will send that link out to everybody who has registered for the webinar. So if you know somebody and they want the link, you can always tell them to go register and then they'll get that link. You will get it whether you want it or not. So you might as well have fun with it, right? Yeah, so with that said, do some quick introductions here. I am Kelly Cohn. VP of Industry Strategy here at ClearEdge 3D. Spent a lot of time in the industry working at a design build firm. Did a lot of speaking nationally, internationally. As Zoltan said yesterday during the practice session, he can personally attest that I play guitar poorly, but cannot attest that I dance moderately well. So we may have to work on that, Zoltan.
Of course.
And Zoltan, I'll let you introduce yourself.
Yes, of course. I'm Zoltan Ferenczi. I'm industry strategist working with Kelly Cohn here, and I come from a long history of CAD drafting and architectural design background, probably about as long as I've been alive. I've also worked at Autodesk training centers and Autodesk resellers, and I've also had my fair share of being out in the field and doing laser scanning. And like most people at ClearEdge 3D, I'm an avid rock climber, and it is true, we all get good at falling.
I slipped that one in there on you.
Yeah.
All righty. So yeah, and with that, Zoltan, take it away, and I'll pop in later for talking about Verity Photo.
Absolutely. So we're going to talk about the Verity software, and what it essentially is a plugin that runs inside of Autodesk Navisworks that gives general contractors and engineers the ability to compare their coordination models inside of Navisworks with true as-built data that's captured with laser scanning out in the field. And this allows them to not only validate whether things have or have not been installed, but automatically to determine if things are in tolerance or out of tolerance. And then with all of this information, we can adjust the coordination model in Navisworks to match the true as-built condition, and also use it to generate reports that we can then communicate to the design team or integrate with online issue tracking systems like Autodesk BIM 360, BIMTrack, and Procore. So I'm going to jump right into the demo here. And for those of you who have not seen or are familiar with Autodesk Navisworks, it is essentially a coordination and management software for 3D building information modeling. Architects and engineers will send general contractors 3D models that represent the architecture of the space, maybe parts of the structure and the MEP, and all of these three-dimensional models come together in Autodesk Navisworks, where the general contractor can then do interference checking and collision detection to see if the different design trades are bumping into each other or having problems. That's good and fine when it's all in the hypothetical design. But as we all know, things aren't always built the way that they're designed. So part of the general contractor's role is to ensure that what is being built matches this design model. So recently, general contractors have been utilizing laser scanning as a way to capture as-built conditions and compare them to this design model. Autodesk Navisworks doesn't really give us a lot of tools for being able to do this coordination other than just visually inspecting the elements. So the general contractors would typically walk through the model, look at places where the scan doesn't match up with the models, and then mark things up and make decisions based on that information. It's a very time-consuming process. So the Verity software automates this process by taking a selection of elements that we want to coordinate and parts of the point cloud, and then analyzing that information to do this coordination automatically. So here inside of the Verity console, we see all of the elements that we've sent in for analysis, and I can then specify what is the item tolerance that we're interested in, and Verity will then analyze the point cloud data around each of these model elements, about a foot or two in each direction of this 3D geometry, and look for that geometry represented in the point cloud data. It uses some fairly advanced computer vision algorithms to then take a copy of that design data and try to fit it to the point cloud as best as it can to create a true as-built representation. Now, it may find the element and is able to fit it, or it may not find the element, in which case it's either not installed or the software can determine if the element is occluded, for example, by something else that was in the scan data that hides the element that we're looking for, or if it's not occluded and it's not found, then it could mark it as having not enough data or being uncertain. So what we get from this is kind of the first step of what general contractors are typically doing with laser scanning, and that is to determine if things are installed or not. And the other thing that we get is to see if the things are within tolerance or not. So after a couple minutes of processing, it gives us immediately a summary report that lets us know that only 2 of these elements are within the 1-inch tolerance, and about 8 elements are out of tolerance. It detected that 2 were not found. These are most likely not installed, and 3 of them are occluded so that we can't actually see them because of things in the way. So if I look at the elements here now, what I see is not only do we have the geometry from the coordination model, the one that we sent in from Navisworks here in the purple, but here in the light blue is a copy of that geometry that is fit to the point cloud, which makes it an as-built representation. So this is the true as-built position of this element out in the field. Now, I will make a little point that part of this process involves having the laser scan data and the coordination model in Navisworks be all in the same coordinate system. This is typically done by general contractors by using survey controlled laser scanning techniques, so that when they capture the point cloud data, they use some registration targets that make sure that the point cloud is matched with the design model so that we're not doing any manual alignment. So all of the deviations between the coordination model and the as-built model truly reflect what's happening out in the field. So after the analysis is done, each of these elements now gets a number of properties. First, it specifies if it's installed or not, whether it found it or it didn't, and whether it's in tolerance or out of tolerance based on the tolerance values that we've specified. These tolerances are based on the total transform of the difference in how far that as-built model is from the as-designed model. And we see that here in total translation. And so we see that this beam is about 1 3/4 inches away from where it's supposed to be. But it also breaks down this information into a number of different directions. For example, it gives us the vertical translation, which is only about 3/8 of an inch. If we're only really concerned with the elevation of this beam and we have a lot greater degree of tolerance in the X and Y direction, we can see here that maybe this isn't really going to be a problem. It also gives us information about the rotation and the other axis and directions so that we can make decisions based on whether this is going to be appropriate for our design or if it's going to cause problems. We can also take some measurements here and do some more analysis. For example, if we're interested in a particular point on the element, which is a critical clearance, then we can take measurements between the as-built model and the as-designed model to get a better sense of how that's going to impact the design. Here, for example, we've got this 14-inch pipe, and we can see that this is quite a bit out of tolerance. It's almost 7 5/8 inches below where it should be. Now, beyond this information of just seeing the as-built offsets, we also see the point cloud information, and we can use this to determine other information such as how the element is deformed. Now, first, what I'm showing here is just the distance of the point cloud to the as-built model. This is typically what this kind of software would give you if it didn't have an as-built model, because most of the time, these laser scanning coordination softwares only give you heat maps that tell you the distance between the point cloud and the as-designed geometry. But that doesn't really give us any information. As you can see, these points are far away, these points are close by. It's not very useful. When we have an as-built model, we can actually start to look at the deviations between the point cloud and the as-built model to let us know where these deviations actually occur. This can show us how elements can bow, or if they're sheared, or in other ways deformed beyond just being moved from the as-built condition. Now, if we want to take a look at where this is in Navisworks, we can match what we see in Verity with what we see in Navisworks by linking the two views together. So as I move around and observe this object, I'm seeing in context where it exists in the rest of the coordination model. I can also turn on a section box so I can isolate the element, or I can use this inspection mode, which hides it or kind of makes everything else transparent so that we can see better in context of where this occurs and how it impacts our design. So let's take a look at some of these other elements here. Here we've got a steel column, and this column has been marked as not found by the Verity algorithm. There may be a number of reasons for that. Either it didn't have enough point cloud data, or the algorithms are not exactly perfect. So we can override this, say that it actually is installed, and I can manually position the element as soon as I'm not measuring it. I can manually position the element based on what I know about where it is. As I move this around, I can recalculate that heat map, and it gives me the new metrics for the total transforms, and it specifies whether it's in tolerance or out of tolerance. Let's look at another one of these. Here we've got this, this wall. I'm going to kind of find it here in the point cloud. Oops. Let me get back to it. I'm going to turn off the inspection mode a moment so I can then get to it. Give me a second.
The joys of navigating Navisworks.
Yeah, Navisworks is always a fun animal to try to get your head around where exactly things are in the world.
It's behind you now.
Ah, it'll sneak up on you.
There it is. Oh, you went past it. A
All
little
right,
more. Boom.
there's the guy. Okay, so this element actually is not found. We can look at the point cloud data and see that it hasn't been installed. So once we make these determinations, we can quickly go through this list of items and then approve or not approve these results. And all of this becomes information about the coordination review process. So we can communicate all of this information to the stakeholders and the rest of the design team in a number of different ways. Beyond just the reports that we produced for the percentage of things that are in tolerance or out of tolerance, we can create a number of HTML reports for each item's information individually. So if I create an HTML report for each of these items, what it gives me is not only a table of the metrics for each element, whether they're in tolerance, out of tolerance, you can see the ones that I've reviewed, but each of these elements also has a sheet that shows the graphical views and all of the metrics that are associated with it. Now, beyond that, we can also push these results to various online issue tracking systems, such as Autodesk BIM 360, BIMTrack, or Procore. And in Procore, we can specify that these are either issues or observations, and we push not only the issues and all their metadata, but also the images that we produced with the heat maps and the as-built locations, and also the camera positions in Navisworks, so that Procore's Navisworks integration can take us right to those locations. And then we can use that as a way of communicating this information with people who maybe don't have Verity. Now, for the rest of the designers that may not have Verity, there's a number of ways that we can leverage this information inside of Verity. One way that we can do this is we can take all of these elements, I grab all of them, and push these properties into Verity. What this does is it will essentially color each of the elements by their installation status. So the things that are passed are green, the things that are out of tolerance are yellow, the things that haven't been installed are red. And beyond that, we can also see the properties in the properties palette here inside of Verity. So we can see all the transform information and get information about what those deviations are. Now, there's more. We can even take the as-built position that we've determined inside of Verity and push that to the Navisworks model. So if I push the as-built position, it applies that transform to each of the elements inside of Navisworks. So now what we're looking at is a true as-built coordination model. We can export this out as an NWD, send it to the rest of the design field, and have our other divisions of trade be able to coordinate their work with it, or we can rerun our clash detection to see if subsequent divisions of trade that have not yet installed their work will have issues with this true as-built position. So what I've done here in just the last 10, 20 minutes or so is the kind of tasks that general contractors do on a day-to-day basis, and they spend a great deal of time. And as you can see, this software greatly enhances and speeds up that workflow. What do you think, Kelly?
I think that pretty well covers it. Yeah. I mean, I always like to tell the kind of story of Verity's birth to people, which is, I ended up on a very high tolerance job site about, 8 years ago, and we had to use laser scanning to validate a whole bunch of work on that job because it was the only way to efficiently do it. And efficiently being in air quotes, because you'd spend a couple hours scanning and you'd spend like 2 or 3 days walking through the model, making sure everything matched the scan data. And that's back when scanners were slow. And so, this was kind of born out of that idea. And there were a couple other people in the industry, David Epps, and just a number of other people that we were all doing the same thing on jobs, and had come to ClearEdge and been like, you should make this software because it would make our lives better. So it's always fun to see it. But yeah, and of course, you can always export out those heat maps and stuff and bring them into Navisworks as well, send them off to people in Revit or anything else. So yeah, that's pretty much covers it. Yeah,
All right, tell us
so
about Verity Photo.
yeah, absolutely. So that, we started with the high accuracy, we started with the NAS ass. Now we're gonna zoom out, and you'll have to listen to the horse's ass since I'm the one talking now. So this is kind of a companion for Verity, and the way I like to describe Verity Photo is, likewise, back when I was working on that and many other jobs, if you've ever had the pleasure of like this beautifully coordinated model and you walk out in the field and the subs actually installed it correctly and you just have to take a picture of it. And so, you get your phone and you take a picture, and then you go back into the office and you're sitting here trying to get the view frame and the model to line up to the image because you want to see that the work was installed correctly, and you just, it's not a lot of fun. So, Verity Photo is, in a nutshell, a tool that makes it easy to accurately align images taken in the field with the app to the coordination model inside of Navisworks. This is a very simple tool. It's also nice and cheap. It's, less than $1 a day. And you basically, you get the app for free. The plugins, what you pay for, and these two things together will let you go out in the field, take photo documentation, and pull them into Navisworks and be able to have those photos aligned to the model and compare them. So with that, let's take a look at how this actually works. So I mentioned there's an app. So to get the best results, we have a little calibration step where you throw something up on a monitor, take pictures with your phone. It lets us calibrate your camera and do any kind of corrections to it. We also can locate, basically using a map that you export out of Navisworks. And so you kind of get to a plan view, identify what you want to dump out, and then you've got your location. And then you want to go through the capture. And Sultan, it's strange. I think the autoplay has failed me. Oh, there it goes.
Yeah, you set it up.
I was just impatient. Apparently,
we got it.
Boom. All right, lovely. So, in the case like this, you open the app, you hit that capture button, you take a photo. There's some basic markup functionality, and then once the photo is captured, you've added your markups, done anything else you want to do, yelled at a guy to get off a ladder because he's blocking the way. You're going to take that, and then you basically send that off as a, if you're a foreman or a superintendent, you're going to send that off to whoever's kind of running your coordination on the job. Generally, superintendents and foremen aren't that comfortable in Navisworks, but they're quite happy using an iPhone. The VDC guy back in the job office trailer, right? He basically loads in those photo notes, pulls them in, and based off that initial location they made in the field, it'll snap you to that part of the model, and then you click on similar lines. So you basically find edges, corners, walls, ceilings, floors, and then just by picking on a couple lines, we can get a very, very accurate overlay, and you can change the transparency back and forth. And so this lets you see, is the ceiling grid in the right place? Do we have, the MEP in the right place? Yeah, so we can go ahead and jump to the next video.
Yep.
Yeah, that overlay kind of gives us a base source of visual comparison. But there's some other things we can do with it. First off, there's some nice little reports in terms of just documenting where the photos were taken on the project and showing those photos and any markups. So once you've done your overlay in Navisworks, you can also add markups and notes, and then all of that stuff will get saved out to the report. And that's a PDF you can ship off. So this is a great little punch list tool, just in terms of finding little problems as they relate to the model, and showing people that hey, we're in this hallway or we're in this open space. We went and took these photos. Here's where they're located. You can go to this position, look in that direction, and then we've got all of the we've got all of that imagery with the overlays and everything else associated with it. So this is just a nice, simple, easy tool to basically get these various different photos and model overlays pulled together and use them for punch lists, use them for QA/QC, use them for whatever floats your boat. I feel like the video froze for some reason there. When has it ever been that videos are
it's always dicey to stream videos to a webinar
versus live demo? It's like, oh my gosh. I'm always terrified of live demos, and the video has failed me. but yeah, anyway, and we can do all that stuff, take some basic measurements, but it's a really nice tool to just super simply get some basic QA functionality as it relates to a coordination model, and get that out in the field, and get your foremen and your superintendents participating in that process and getting a little more comfortable what's supposed to be installed. So yeah, and with that, we are through the outbound content. So let me crack open the Q&A stuff here, and we can take some questions. Pull that off so I can actually see more than one. Can you use 360 photos? So we do not in Verity Photo support 360 photos. There's some really great tools out there that are kind of focused on 360 cameras. Verity Photo specifically works with iOS devices. You have to capture the photos using the app. And right now it's just an iOS application. So also does not work on Android. All right, we've also got a question here. Let's see if I can crank through some of these. Got a number of people asking similar questions. All right, is Verity Photo a separate product to purchase? So if you are a Verity customer, you get Verity Photo for free. Yeah, we bundle Verity Photo with our Verity licenses. I think you need to just reach out and talk to us if you don't have it turned on because you haven't asked for it. If you are not a Verity customer and you're not paying for our kind of Verity suite, you can just buy it standalone on the Autodesk App Store, and it's like I said, it's basically $1 a day for the year. Verity itself, we've got a couple people asking about that. The Verity suite is $3.99 a month. That's the kind of annual price breaks down to $3.99 a month.
Here's a good question for us, Kelly, on Verity. It says, what is the minimum recommended scan density for input? This is actually a really good question because there's a lot of people that do a lot of high density laser scanning out in the field, taking gigs and gigs of scan data because they want to be able to see things very clearly. But since our algorithm uses computer vision that is a lot different than human vision, we actually don't need that much laser scan data to be able to get good fits inside of Verity. So you can speed up the process greatly by subsampling the point cloud data that we use for the analysis in Verity. And what would you say, Kelly? We could take it down to maybe almost a 1/4 inch grid and get decent data?
Yeah, I mean for Verity is because you start with geometry, it's just a lot less sensitive. We're not trying to figure out whether it's an I-beam or a angle iron or something. We already know because that's coming from the model. So yeah, I mean, I typically, for larger stuff, I typically recommend either a half inch or so a half inch resolution on the scan data in terms of what you capture in the field, uh, down to, a quarter of an inch if you're capturing smaller stuff like, 2-inch pipes and conduit. Um, for really large things, you can scan at even lower resolutions. If you have
And
reason to
this is
scan at
the
high,
scanner setting 1/4 inch at 30 feet from the scanner,
yeah,
not 1/4 inch grid.
yeah, 25 mils at 25 mils at 10 meters, 12.5 mils at 10 meters. Yeah, the settings in the field, because you can save a lot of time by scanning lower res in the field. If you need to scan at a higher res because you have other purposes for the point cloud, then yeah, you're spot on, Zoltan. When you index the scans into recap, because we basically read the scans out of recap, so you have to index them in recap to bring them when you bring them into Navisworks. If you're using them with Verity, yeah, you can do a 12.5 or half-inch grid decimation, even up to an inch grid decimation for larger stuff most of the time, and it's usually still way more points than we need to get a really solid match between them, but that way smaller stuff doesn't get dropped out. So there's some good pro tips in some of our other Verity webinars, just in terms of indexing one or two different scan densities with different settings, so that you have a higher res scan for the half-inch conduit you want to test. But for most of the larger stuff that you test, you can use the lower res scan, and it's just processes much faster.
Right. Here's another good question. Is there any limitation regarding the number of analyzed units? And the answer is, well, kind of no, if you're willing to wait a long time. The amount of processing time is linear with the number of elements that are analyzed, and I wouldn't recommend analyzing 10,000 pieces of steel inside of a complete high-rise structural model, but you can
Yeah,
analyze many hundreds of elements in under a few hours. What's your experience there, Kelly?
yeah, I mean, I generally tell people that the human brain and its ability to wade through 5,000 beams is the limiting factor, not the computer. Uh, so yeah, I always recommend, when kind of training customers, that you kind of break your analysis up into or small sections, and you analyze each section independently, because that allows you to look at level one steel, or level one area A steel, so that you can kind of wrap up a deliverable for level one area A. You can publish the report, send that stuff off, and it kind of breaks up your day, because even this is 10 times faster than visually walking through and checking every element, but it's still a mind-numbing process to flip through 5,000 steel elements and look at them. So definitely break it up into smaller chunks. Processing will be faster. We have somebody ask, how long does it take to check a 100 megabyte 3D model? And I would say that the size of the 3D model has very little to do with the amount of time it takes to process. So the amount of the laser scan data is by far the biggest, and the number of objects are the two things that are the kind of the influence processing time. So number of objects scales pretty linearly, but since scan data, just like TV monitors or anything else, it scales quadratically. So if you have a scan that's twice as dense, it will take 4 times longer to process, because there's 4 times as many points, right? So 10, and then likewise, if you have 10 scans, versus 20 scans versus 50 scans versus 100 scans, like as you get more scans, the analysis time goes up a lot. So that's another reason to break it up into smaller bite-sized chunks.
Here's another good question. Are the scans registered before importing? And absolutely yes. Since Verity works inside of Navisworks, we want to bring the scan data registered from the laser scanning manufacturer's scanning registration software as a complete point cloud into Navisworks, along with any of the design data or fabrication data, coordination data, whatever. And as I had said before, one of the things that's important to get all of this workflow to work the most accurately is these laser scans should be registered to the coordination model's coordinate system in the field. If you were to manually try to align the scans with the model, then any metrics of deviation between the as designed and as built model would always be questionable as to whether those are a result of your registration error. And so typically the workflow is when the laser scanning is done out in the field, there are some laser scanning targets that are put out that are then surveyed using surveyors' total stations or other surveyors' techniques, such that the laser scan point cloud is transformed into the same coordinate system that the coordination model exists, so that when we bring them into Navisworks, they're already exactly in the same place, and any deviations between the as-built and the as-designed geometry is a true deviation between what's been designed and what's been built. So it's very important to note that the registration of the scans in the model are very important.
Yeah, absolutely. And as you mentioned, Verity is a companion to Navisworks, as is Verity Photo. So both of them require Navisworks. So I know we had somebody ask that as well. Yes, if you don't have Navisworks, you cannot run either piece of software. I really liked this particular question. How to evaluate the software algorithm? What algorithm is used in the comparison?
Well, it's all magic, of course.
Yeah, Karam, we're not going to tell you the algorithm because that's our that's our trade secret. But it's a custom algorithm that we've written. But what I would say is that in terms of our internal testing, we're using tens of thousands, if not hundreds of thousands of points to match a rigid fixed body to a point cloud, and it's mathematically it's extremely accurate. There's fractions of a millimeter in terms of the mathematical optimization, but I think the flip side of this is we also need to remember that no beams installed are ever perfectly flat, and whereas our models of beams are always perfectly flat. And so there's always some kind of surface variation in the field. There are always, there's obviously accuracy of the laser scan itself, the accuracy of the registration. So the general answer is that the algorithm, of course, is not perfect because there is no perfect algorithm, but the fitting algorithm is extremely accurate, and the algorithm is not the thing that bounds the accuracy in 99.9% of cases. It's actually the accuracy of the scan data, the variation between a perfect model and a realistic installation. Those are things, and then of course any registration error. Those things are actually much larger impacts on accuracy. But we've got people that are, regularly using Verity to look for, 3 millimeter to 6 millimeter variations in steel structural install. So, and these people are getting good, confident results that they have benchmarked against traditional mechanisms like using total stations to take the same measurements set up on a control network. So, we feel quite confident in the overall accuracy. But of course, as I said, when there's large variances between what actually got installed and what's in the model, that's why, a person is always, recommended to look at the results, because, people also don't always even install the right size or the right shape of thing. And that's not something our algorithm can handle or detect, if that makes sense. Yeah, and then actually, somebody else asked, can you use Verity as an as-built model checker? And so Zoltan talked about Verity as a construction QA/QC tool, and both Verity and Verity Photo are kind of targeted at that. But we actually have a lot of our customer base for Verity that focuses on this workflow. So particularly companies that outsource scan to BIM modeling to third parties. Verity is a fantastic way to kind of consistently and automatically compare the as-built model delivered to you by a consultant against the point cloud to make sure that they've done their job to specification. So this is definitely a common use case for us.
Another interesting use case is oftentimes as-built models are not truly as-built, but they're old design data. If you've ever worked on an architectural project that's a renovation or an adaptive reuse project, oftentimes you'll have some documentation for the building that is just the old construction document. And part of the task of creating an as-built document from that is determining how what actually got built differs from what was designed. So one of the things that you could use Verity to do is to take a design model and turn it into an as-built model by looking for the areas where it deviates from the true as-built condition. So it's not always all about general contractors doing construction coordination.
Absolutely, absolutely, yeah, and that's it's actually kind of design firms that are doing the thing I was talking about also are doing the thing you're talking about with getting as-built models from owners. If there's a existing Revit model or 3D model that they can get from their client before starting design. But it's particularly, I've heard of a lot of general contractors doing what you're talking about, Zoltan, because they get basically an itemized list of deviations between the point cloud and the design model of the existing work. Nice itemized report that they can then load up into RFIs and send off to make sure that those things get documented and addressed. Not that that's something any architect looks forward to getting, but it's a really useful way of documenting it. Let's see here. For Verity Rhythm, wondering how to make sure the scan is perfectly lined up with the design model. So we talked about this a little bit prior, but I actually like that somebody else tossed in a tip. So I wanted to bring this back up about using Autodesk point layout to extract coordinate information from a coordination model and then be able to use that to help register a point cloud to the model or the model to the point cloud, which I thought that was a pretty cool pro tip from one of the people watching.
Yeah, and also Verity Rhythm, which we didn't talk about or show, is kind of a companion product to Verity that gives the same workflow inside of Autodesk Navisworks, but geared towards floor flatness analysis, wet concrete pour deviation analysis, volume calculations, ASTM E11.5 reporting, E1155 reporting, and also other ways of determining if things that are concerning the flatness of floors or the way that concrete slabs are poured. It gives us a set of analysis tools.
Yeah, and and then we've got a processing speed question. So this gives me a great excuse to tease. Basically what parameters of a computer will affect the processing speed. So for the most part, because we're doing a lot of sequential stuff, Verity is single threaded. So the biggest single impact for processing speed is going to be single threaded performance of your CPU. And then the second is going to be kind of disk I/O, just transferring data, moving data around. So you'll definitely find it runs faster on computers with solid state drives than on computers with mechanical drives. However, we currently have a version of Verity and Rhythm in testing that we hope to have out by the kind of end of next month or early the month after, that will process data about at least twice as fast as we're doing it right now in Verity, and about 4 times faster in terms of bringing that data into Rhythm. So a pretty big speed up for us is coming down the pipe very soon, Verity is still a way faster than doing it manually, but for any of our existing customers listening, I know a 2x or a 4x speed up will be nonetheless greatly appreciated. Yeah, and then Zoltan, I don't know if you, well, for people listening, we've got in 2 weeks another webinar coming up focused on rhythm. So look for the tweets or the LinkedIn posts or the emails because we've got that floor flatness focused webinar coming up soon. So.
Yep, I think that looks like just about all the questions that we're getting, unless anybody has any others.
That's fantastic. Well, thank you all so much for chiming in and asking questions. Thank you for listening. We'll let you get out of here a little bit early. Let us get out of here a little bit early too. Really appreciate the time. Thanks for joining us, and see you on the next one in 2 weeks.